Hello friends, Mr. Burrell here. We're in Unit 2 talking about statistics. We just talked about, in 2.1, we talked about a bunch of different definitions associated with statistics. We talked about populations and samples. We talked about different kinds of studies that you can do, surveys, experiments, observational studies. So now we're going to move on, and we're going to talk about random sampling and bias. So as you go into a situation where you perform an experiment, or you do a survey, or you do an experiment, and you're collecting data, it's important to recognize random sampling and bias. So this is something that statisticians and people working with statistics have to deal with and recognize a lot. So we're going to talk about this. So by the end of this lesson, this is what I hope you're able to do. Identify the type of sampling method used for from the following. We're going to talk about 4 different sampling methods: random, stratified, cluster, and systematic. So we'll talk about those. We're going to identify what may cause a sample to include bias. We'll talk about bias, what bias is, and identify what causes a sample to include bias. And then be able to evaluate what may cause a sample to be random. So this is what you're going to be able to do by the end of this lesson. So some definitions. When I say sampling, what that means is the act of gathering a sample from your population during a study. So in the last lesson we talked about the difference between a population and a sample. The population is everyone that I'm concerned with, and then the sample is just a handful of objects or people from that population. So when I'm talking about sampling, it's the act of gathering that sample. How do I choose the people in my population that I'm going to use in my study? Random is the lack of pattern or predictability in events. Each outcome has an equal probability of occurring. So random sampling is being able to gather a sample from my population such that every single person has an equal probability of being selected. So instead of just like choosing like, oh, this is really convenient, I'm going to choose these people to be in my sample, a random sample, random means that everyone has an equal probability, an equal opportunity of being selected. Inference, whoops, let me just cross that out there. Inference means coming to a conclusion about the population based on the sample outcomes. This is what statistics is all about. In statistics, we're wanting to make inferences, we're wanting to make predictions about a population based on a sample. In order for those inferences to be accurate, the sample has to be representative of the whole population, which is why we want to have a random sample, because then I can have a good idea that the sample that I have does indeed represent the whole population. Okay, so those are the first 3 definitions that we're going to be kind of experimenting with here. So, some different types of sampling methods. There's a simple random sample. A simple random sample is where each element of the population has an equal chance of being selected for the sample. So this might be put everybody's names in a hat, draw them out at random. Everyone has an equal chance of being selected. There's like random number generators. I'm going to show you one of those here in a minute. Random number generators on the internet where you can assign everyone a number and then randomly select a number. But a simple random sample means every person or everything in the population has an equal chance of being selected for the sample. Stratified sampling is where members of the population are first divided into groups, and then a simple random sample is taken from each group. So I split my population into groups, however many groups I want to divide them into, and then I take a random sample from each group. That's stratified sampling. Split the population into groups, take a random sample from each group. Cluster sampling is where the population is split into groups, and then a random selection of groups is taken. So say I split the population into 100 groups, I randomly select a certain number of those groups to include in my sample. So say I have 100 groups, and in each group there's 10 people, and say I randomly select 10 of those groups. Each of the 10 people in those groups I include in my sample. So that's a cluster sampling method. I divide my population into groups and then randomly select different groups. The last one we're going to talk about is systematic sampling. And that's when you determine an nth position to select, and then select every nth member of the population. So say I line everyone up in my population, order them from 1 to 1,000 or something, if there's 1,000 people, and I'm going to select every 5th person. So I'm going to select the 5th person, the 10th person, the 15th person, the 20th person, the 25th person. Every 5th person, every 5th person, I'm going to select to be in my sample. So that's systematic sampling. I follow a certain system. Every 5th person, or every 10th person, or every 15th person, whatever it may be, that's a systematic sampling. So let me give you some ideas. So a simple random sample is I have everyone in the population and I just randomly select a certain number of people. In this case, I've selected 5 people randomly to be in my sample. Again, that could be drawing out of a hat, that could be a random number generator. I randomly select 5 people to be in my sample. The next one we talked about was stratified sampling. Stratified sampling is when I split my population into groups. So you see I have 1, 2, 3, 4 groups that I've split my population into. And then I randomly select, in this case, a few people from each of those groups. So I selected 1 from each of these groups, 2 from these groups. Stratified sample is when I split my population into groups and then randomly select people from each group. A cluster sample is when I split my population into groups and then I randomly select a certain number of groups to include in my sample. So in stratified sampling, I split them all into groups and then just chose a few from each group. Cluster sampling is I split them all into groups and then just select a few whole groups to include in my sample. Systematic sampling is when I pick every nth person. So like here's my first person, 1 to my second person, 1 to my third person, 1 to my fourth person, 1 to my 5th person. So I follow a specific pattern in selecting the people who are in my sample. Okay, so let's look at some examples. So say I have the population of Box Elder High School. I have the population of everybody in our school. How would these different sampling methods look when trying to select a sample from everyone in our school? So a simple random sample is I have everybody in the school's name, and say I put them in a hat. I put them in a hat, and I draw their names out at random in order to collect the people in my sample. That would be a simple random sample, is I put everybody's names into a hat and grab names out at random. Another example of selecting a random sample, say we have 1,500 people in our school. This is just on Google. I search random number generator here. So say there's 1,500 people in our school and I assign every single person a number. Maybe I line them up all alphabetically, give them a number. When I click this generate, this is going to randomly select a number. So I'm going to select the 881st person, the 960th person, the 84th person, the 409th person, the 1,245th person. I just randomly generate numbers, and whoever that number is assigned to, that's who is included in my sample. That will make sure that I have a good representative of a bunch of different kinds of students, a bunch of different grades, things like that. So a random sample is everyone has an equal chance of being selected. A stratified sample, maybe I split all of the whole school into groups. So let's split the entire school into each of their first hours. So I split the whole school and I look at all their first hours. That's my groups, is everyone in their first hour. And I have all these people in each hour. So a stratified sample would mean that I select randomly like 3 people from each class. I select 3 people from each class, and those are the people that are in my sample. So stratified samplings, I split my group, my population, in this case my school, into groups, and then I randomly select a few people from each of those groups. Cluster sampling, again, using our school example, I'm going to split my school into groups. Again, I'm going to look at all my first hours, and then I'm randomly going to select, say, 3 of those groups. So cluster sampling is when I split everyone into groups, and then I randomly select everyone in say these three groups. So everyone in this class, everyone in this class, and everyone in this class, that's who's going to be in my sample. A systematic sampling, say I line everybody in the school up side by side, and I go through and I select every sixth person. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, etc., etc., etc. A systematic sampling is I go through and I select every sixth person, or every 10th person, or every 20th person systematically. I follow that pattern. So in different situations, we're going to see this in our assignment and in the real world. In different situations, some of these sampling methods might be more beneficial. Some of them might be easier to do. Like, for example, if you already have a population that's split into groups, like classes in a school or states in the United States, it might be nice to use a stratified or a cluster sample. Or if you're watching people come into the grocery store and giving them a survey, it might be easier to just say every 10th person that walks into the grocery store. It just depends on the situation which of these sampling methods you might use. Okay, we've talked about sampling methods, now we're going to talk about bias. Bias is prejudice in favor of or against one thing, person, or group compared with another, usually in a way considered to be unfair. As a result, the sample is not a good representation of the population. So I like this little comment. Give me a moment to find unbiased data that supports calling you and your ideas stupid. Anyways, so bias is prejudice in favor of or against something that makes the sampling or the situation unfair, and thus the sample would not be a good representation of the population. So, for example, if we were going in our school and I was trying to calculate how many people were enrolled in a math class, and say I only went down the math hallway and I took people from each math class and asked them if they were taking a math class. Well, everyone down the math hallway would be taking a math class, so that's not a good representation of what the whole school is doing, because I'm only asking the math classes and their students if they are currently taking a math class. If I go into the language arts hall or the social studies hall or down to the PE hall, it's more likely that some of those kids are probably not taking a math class this trimester. So I'd want to make sure that the sample I take is representative of the whole school, not just the math hallway. That's just a short example of bias. It's prejudice in favor of or against one thing that makes the sample not a good representation of the population. So there's a few different examples of bias. This is not a comprehensive list. There's tons of different kinds of bias you can run into when setting up statistical studies and surveys and these different experiments. But these are some examples of selection bias. So from the researcher, from me, if I'm trying to select a sample, these are some examples where bias kind of comes into play. Convenience sampling. Subjects are selected because they are easily accessible to sample. Sometimes not. That will present bias because just because people are convenient to be able to include in your sample doesn't mean they're going to represent your population. Quota sampling means a certain amount of specific people with required characteristics have to be in the sample. If you have certain people that need to have certain characteristics, like say they work at a certain place or they go to a certain school, that might not represent your whole population because they all have very similar characteristics. Under coverage, sample of a certain part of a population is too small. Maybe you don't have enough people in your sample. Question order bias, order in which questions are asked. Sometimes if you're like giving a survey, the order that you ask your questions can kind of sway people to answer a certain way. Question wording bias, the way questions are phrased. So a lot of times people will be like, in a survey they'll say something like, do you support the brutal imprisonment of animals? And when you phrase it that way, when you word the question that way, lots more people are going to say, no, I don't support that, even if maybe they do, just because of the way it's worded. Healthy worker effect, as sample researchers, research is a characteristic of a mostly absent population. So like maybe there's just not a lot going on in the population in question. Hospital patient effect, those surveyed are most susceptible to the variable. So like if you're trying to determine the results of a drug or the effectiveness of a treatment, if there are certain people that are obviously going to benefit from that treatment, and those are the people in the sample, that's not very representative of the whole population. Confirmation bias is bias hypothesis to confirm a previous belief. Culture bias assumes results before even being gathered. So like you assume what you make an assumption about what the results are going to be before you even collect data. Those are all examples of bias. Again, this is not a comprehensive list. There's tons of examples of how researchers, like creating studies, can be biased. The other kind of group of bias examples is response. So like from the sample. So non-response bias means a large part of the sample doesn't respond. So say you like randomly select a big sample of people and you send them all an email survey. Non-response bias would mean like a big chunk of those people don't even fill out the surveys, so you don't have enough responses to even formulate an opinion. Volunteer bias, sample chooses to participate. So like surveys like on Facebook or surveys that the radio sends out, when people just have an option to choose, that's often not a very good selection of people because sometimes those people are heavily invested in the survey and their responses will be biased. Social desirability bias, answer according to what is thought to be the desired answer. Sometimes if you're going through, instead of answering honestly in a survey, people will answer just to please whatever the survey person is trying to get across. Acquiescence, I think is how this is said. I'm not completely positive. Bias is just where you agree with everyone. Sponsor or funding bias, funding source of the survey biases the survey. So maybe like people are giving rewards for filling out the survey or something like that. So there's lots of different ways that surveys can be biased. And that's not okay. When formulating research experiments, observational studies, all these different kinds of things, the results need to be unbiased in order to make an accurate inference about the population. So ways to deal with bias, placebos. We see this a lot like in the medical field. When trying to determine if a treatment works, you'll give like a selection of people the actual treatment and a selection of people the placebo, which means the placebo won't have an effect on anything. And then you can accurately determine if the treatment actually works because everyone gets something, and then we'll see what patients actually see results. Blind experiments, so like A blind experiment would be that people don't know the results or don't know what's being done, so that it's a little bit more unbiased, so people can't be swayed one way or the other. There's lots of ways to deal with bias, lots of examples of bias, but it's important to eliminate bias as much as possible in studies so that we can actually make accurate predictions from our study, from our experiment, or whatever it may be, about the population. Okay, let's look at an example. This is a question off of your homework assignment, so if you printed off your homework assignment or if you have your homework assignment, you can follow along with this one. This one's question number 4 off the homework assignment. It says, after a recent hotel stay, I received an email from the hotel asking me to fill out a survey regarding my satisfaction with my experience at the hotel. In return for filling out a survey, the hotel would send me an Amazon gift card. The hotel analyzes the data from all responses to such emails. So the hotel sends out a survey to every customer and says, fill out the survey, tell us how your experience at the hotel was. If you fill out the survey, we'll give you an Amazon gift card, and the hotel will analyze that data to determine customer satisfaction. So, question A, do you think these survey results will accurately portray customer satisfaction? Why or why not? So this is just like, what do you think? Do you think these survey results will accurately portray customer satisfaction? Well, in my opinion, if I go to a hotel and I leave and they send me a survey, and then for filling out the survey I get a free Amazon gift card, even if my stay was less than desirable, I'm probably going to be like, oh yeah, you guys did great. I'm getting a free Amazon gift card. Sweet. So in my opinion, I don't think that these survey results would probably accurately portray customer satisfaction because there's a reward involved, because they're getting a gift card for filling out the survey. They probably are going to be a little bit biased because they're getting like a reward, a gift in turn for filling out the survey. So I don't think this accurately portrays customer satisfaction because people will be swayed to fill out the survey more positively because there's a reward. And then part B here says, where, if at all, did bias enter the study? Justify or explain how you know. Well, there's a reward. There's a reward for filling out the survey. That's where I think the bias comes in, is because people will fill out the survey more positively, because there's an incentive. So that happens a lot with surveys. If there's like a reward, if there's some sort of benefit to the person filling out the survey, oftentimes they're going to be more convinced to fill it out positively because there's incentive. Pardon my bad handwriting. So that's just one example of a study that was done that includes bias. So this whole homework assignment is you recognizing if there's bias in these different studies, recognizing the different sampling methods that were taken. So that's it. Hopefully by the end of this lesson, this is what you are able to do. I want you to identify the types of sampling methods that are used: random, stratified, cluster, and systematic. Be able to identify what may cause a sample to include bias, and then evaluate what may cause a sample to be random. Because in order for a study to be accurate, it needs to be unbiased, and the people in the study need to have been selected randomly. And that's when you see statistics like in the real world when they're presented on the news or in a funny comic or something. The way the statistics actually are accurate is when they include these things, when they're not biased and when they're random. So I hope that was helpful. If you have any questions, please reach out to me. Please let me know. And I hope that you enjoyed that as much as I did.